Hello everyone, welcome to Prakriya Educations. I am Mallikarjuna. In this module, we shall solve a lot of problems on types of relations. I have chosen the problems from the exercise 1.1 and as well as the previous examples. I have retained the question numbers for your reference. Look at the first problem. Let R be the relation in the set given and the relation R is given by this set. We need to check which of these four options is the right one. Now, starting with, I shall name the set given as A, where A is 1, 2, 3, 4. Relation is already been given. I shall just rewrite the relation. We shall now check whether this given relation is a reflexive relation. Firstly, remember the condition for reflexive relation, that is A, should belong to the relation R for every A belongs to A. Now we have four elements in A and hence 1, 1, 2, 2, 3, 3 and 4, 4. All these terms should belong to R. Only then you can call the relation as a reflexive relation. Checking out these terms, we do have all the terms which we had needed, and therefore you can conclude that the relation R is a reflexive relation. Secondly, checking for the symmetric relation. Remember the condition, if a term A, B belongs to the relation R, then the term B, A should also be in the relation R. Only then you can call the relation is a symmetric one. Now, checking each elements, you have got an element 1, 2 in the relation R. But do you find any term 2, 1 in the relation? No. And therefore, 1, 2 belongs to the relation R, but 2, 1 does not belong to the relation R. One counter example is enough to disprove that the relation is symmetric, and hence you can now conclude that R is not a symmetric relation. Now the last one, checking whether it is a transitive relation. Remember the condition, if you have got two elements A, B and B, C which belongs to R, then an element, see these elements, that is A, C should also be in the relation R. Now checking likewise, you can look that you can take any two elements in the relation R. If you are taking 1, 2, 2, 2, 1, 2 again belongs to the relation R. Yes, 1, 2, 2, 2 implies these belongs to the relation R, implies 1, 2 is also in the relation. This is a true statement. You can check for other two elements, like if I am taking 1, 3 and 3, 2, these elements belong to R, then according to the condition, 1, 2 should be in the relation, and of course 1, 2 is in the relation R, and hence if you are taking any two elements or any two ordered pairs, you can verify that the transitive relation holds good, and hence you can conclude that for any A, B which belongs to R and B, C which belongs to R, then we have got A, C also belongs to the relation R. Therefore, you can conclude that the relation R is a transitive relation. Hence, you can conclude that yes, the relation is a reflexive relation, it is not a symmetric relation, and it is a transitive relation, and therefore check for the option, the relation is reflexive and transitive but not symmetric. B is the right option. Check whether the relation R defined in the set A given by this relation is reflexive, symmetric and transitive. Now let us write the set given, that is A, which is equal to 1, 2, 3 until 14, and the relation R has been given in the set builder form. We shall convert that to roster form because that will be very much easy to check whether the relation is reflexive, symmetric and transitive. In order to check that, we shall solve putting the values for x and y. Now we have got the equation as 3x minus y is equal to 0. Modifying this, you may have y is equal to 3x. Now go on putting the values for x. If x is equal to y, then the value of y will be 3 into 1. Y will be equal to 3. If you are putting x is equal to 2, then the value of y will be 6. If x is equal to 3, then y will be equal to 9. If x is equal to 4, the value of y will be equal to 12. If x is equal to 5, the value of y will be equal to 15. But now there is a problem because the relation is defined on the set A, but here we have got the value of y as 15. But 15 does not belong to the set A, and hence you cannot consider this pair, and hence you can stop until this. Therefore, writing this in the roster form, we get R as the first ordered pair will be 1, 3, 1, 3, then 2, 6, 3, 9, 4, 12. That's it. Now we shall start with the first kind of relation, that is reflexive relation. Remember, A should belongs to the relation R for every A which belongs to the set A. Now look at the relation. You are having 14 elements in the set A, but those like ordered pairs, that is the ordered pairs of the form 1, 1, 2, 2 until 14, 14 is not in the relation R, and hence you can easily conclude that R is not reflexive relation. Look at the second one, that is the symmetric relation. As per the condition, if an element A, B belongs to the relation R, then B, A should be also in the relation R. Take some random element out of the relation R. Yes, I'll take 1, 3 that belongs to the relation R, but we cannot find an element 3, 1 which belongs to the relation R, and hence you can again conclude that R is not symmetric. Then the third one, that is the transitive relation. As per the condition, if elements of the form A, B belongs to R and B, C belongs to R, then the element AC should also be in the relation R. Now you can easily take any two elements from the relation R. I shall choose these two elements since the second elements, this second element and the first element of this ordered pair are equal to each other, and hence 1, 3 belongs to R and 3, 9 belongs to R, but as per the condition 1, 9 should be in R, but you do not find any element of that kind, hence 1, 9 does not belong to R. You can check this, 1, 9 does not belong to the relation R, and hence you can conclude that R is not even transitive relation. And therefore, you can conclude that finally R is not reflexive, symmetric, nor transitive. The next problem, let L be the set of all lines in a plane and R is the relation in the set L defined as R is equal to L1, L2 such that each L1 is perpendicular to L2, and we need to show that R is symmetric but neither reflexive nor transitive. Now, starting with the first one, you know that L is the set of all lines in a plane. We can denote the lines as L1, L2, L3, so on. The set of all lines in a plane. Now, the relation R is given as ordered pair should satisfy the condition L1 perpendicular to L2. Now, starting with the first one, that is the reflexive relation. Now, for reflexive relation, you need to select one single element from the set L. Now, hence I am choosing let L1 belong to the set of all lines in the plane. Now, is L1 perpendicular to the same line L1? If I am taking some line L1, is this line perpendicular to itself? Never. A line is parallel to itself, but a line is not perpendicular to itself. Therefore, L1 is not perpendicular to L1, and hence you can conclude L1, L1 does not belong to the relation R, and hence R is not reflexive relation. Secondly, for the symmetric one, select any two lines. Let L1, L2 belongs to the set of all lines. Now, if L1, L2 belongs to the relation R, then this should satisfy L1 should be perpendicular to L2. Now, if I am taking any two lines which are perpendicular to each other, L1 and L2, L1 is perpendicular to L2 as well as L2 is also perpendicular to L1. Both the ways it is true, and hence you can write L2 is also perpendicular to L1, and hence L2, L1 also belongs to the relation R, and hence you can conclude that R is symmetric relation. Now, for the third one, that is for the transitive relation. Recall that for the transitive relation, we need to choose three elements. That is, I am choosing three lines at a time. L1, L2, L3 belongs to the set of all lines given. Now, if L1, L2 belong to the relation R and L2, L3 belong to the relation R, then it should satisfy the condition L1 should be perpendicular to L2 and L2 should be perpendicular to L3. Now, is L1 perpendicular to L3? We need to now find out this. Now, if you are having three lines where I am taking this as L1, L1 is perpendicular to L2, this is my second line. Then in turn L2 is also perpendicular to another line L3. You can now observe that L1 and L3 are not perpendicular lines, rather L1 and L3 are parallel to each other, and hence L1 is not perpendicular to L3, and therefore you can conclude L1, L3 does not belong to the relation R, and hence R is not transitive. Try to solve these problems and you can send your answers in the comment section. Practice more problems of the same kind to become thorough with the concept of types of relations. That's all for the day. Enjoy doing math. Hope you enjoyed the video. Please don't forget to like, share and subscribe. Thank you.